Hi, Assalamualaikum and very good day to all my friend and our lecturer, TS Abdul Halim bin Dahlan. Our group consists of 5 members, which are Muhammad IRFAN bin Muhammad Matari, Muhammad FIDAUDDIN bin Yusri, Muhammad ADIB bin Syarul Aman, Muhammad ALIFF NAJMUDDIN bin NAJMUDDIN, and Muhammad FARHI bin Khairul Akman. Today, our group will presenting our project assignment for the course BEET Communication Principle for the title project Pulse Code Modulation or PCM. So I will continue this presentation with the introduction. In this assignment project, we are required to design a pulse code modulation on MATLAB and SIMULINK. So basically, we need to know what is PCM. Pulse code modulation is a method used to digitally represent sample analog signal. It is the standard form of digital audio in computer digital telephony and others digital audio application. The most common digital modulation method for analog data transmission is PCM. Then we need to know the function of PCM. The function of PCM is to convert analog information into binary sequence plus code modulation plus a signal. PCM can be processed digitally and resist noise better than other modulation methods.
Example 1, example 2, and the question number 1. For the code example number 1, A equal to sine in bracket 2 multiplied by pi t is analog signal with 1 Hz frequency, while P equal to square in bracket 2 multiplied by pi multiplied by 10 and multiplied by t is square signal with 10 Hz frequency. Figure 1 will plot analog and sample signal. For the figure 2, we'll plot the encoded and decoded signal. For the figure 3, we'll plot the square signal. Here the output for example 1. Figure 1 will show analog signal and the sample signal. Figure 2 will show the encoded signal and the decoded signal. For the figure 3 will show the square signal. The example number 2 is C equal to compend is compress the message signal. For the O equal to compend is expand the message signal. For the figure 1, we'll plot the original signal graph and receive signal using compending graph in figure 1. For the figure 2, we'll plot the original graph and receive signal without compending graph in figure 2. Here the output for example number 2. The red line will show the original signal. For the black line will show as a received signal using compending. While in figure 2, the red line will show as a original signal and the green line will show as a received signal without compending. Question number 1. What is the frequency of the analog signal that have been used in this example 1? Here that we can see A equal to sine in bracket 2 multiplied by pi multiplied by t. The frequency for the analog signal in example 1 is 1 Hz because A equal to sine bracket 2 pi ft is equal to pi t. F equal to 1 Hz.
For exercise 2, we have to generate 2 kHz sinusoid with a peak-to-peak voltage of 2 volt and generate a contrast signal when n equal to 8 and n equal to 16 levels. Then calculate the signal to contain noise ratio SQNR. So for the MATLAB coding, from the example to coding, we change the value at here from 0.01 to 0.0001, and then at here we also change the value from 3 to 8 according to the question asked. So also we add the axis for the figure 1 and then also for the figure 2, and then for the output This is the output for the figure 1, and for the question 2, and this for figure 2. And this is using the n equal to 8, and then we change the value to the n equal to 16. Then run. Okay, this is the output for the n equal to 16. And then to question us to for the calculation for SQNR, this is the calculation similar to quantized ratio. First, SQNR, this is the formula is for SQNR. Then we first n equal to 8, then this then 2 equal power of 3, then n equal to 3, SQNR equal to 2n square root 3 over 2. Then put the n value 3, then calculate, we got the answer 9.798, and then put the value into this equation, 20 log 10 and SQNR. Then we got the 19.82 dB. Also same for the n equal to 16. We put the value and into the formula SQNR and got the value 19.59, and then put the value into the formula, and again we got the final answer 25.84 dB.
Explain about exercise 3. Exercise 3 is use the MATLAB SIMULINK for question 1 and question 2. For question 1, what is the frequency of analog signal that has been used in the example 1? So this is the SIMULINK for example 1. So in example 1, the frequency of the sine wave is 2 pi, but we divide by 100 because the step is 0.01. And the pulse generator is used for generate square wave, and the amplitude is 1, period is 10, pulse width is 50%. And the dot product is used for generate sample signal. So this is the analog signal and the sample signal, and this is the square signal. For encoded signal, we use uniform encoder. This is the encoded signal, and decoded signal we use uniform decoder. This is decoded signal. For question, we ask what is the frequency of the analog signal in example 1. In this, we get the frequency is 1 over 100, but we must divide by 0.01 to get the frequency because the step is 0.01. So we will get 1 Hz. For question 2, generate a 2 kilo sinusoid with a peak-to-peak voltage of 2 volt and generate a quantized signal when n equal to 8 and when n equal to 16. So this is the SIMULINK for exercise 2. First, the original signal. We use sine wave with 2000 Hz and amplitude of 1. And then in the uniform encoder, we put the bit to 8 because the n is equal to 8. And this is the received signal using compounding and the original signal. and this is the received signal without compounding and the original signal. For the n equal to 16, we change the bit into 16. And this is the received signal using compounding for n equal to 16, and this is the received signal without compounding for n equal to 16.
So I will present about discussion and conclusion. For discussion, we got from the PCM passcode modulation above. We can say that it can encode a message by converting them into binary bits. This can rather be called as passcode. Moreover, we found that PCM is resistant to noise and can process digitally. Furthermore, PCM can only be used in a digital number. This means each numbers represent a level of the quantized message signal. As soon as the quantized signal is in the digital domain, it will be much easier to generate signal processing by only applying the required mathematical equation. Apart from that, D such A is converter does the opposite of what an AD converter does. It simply changes digital numbers to analog. So for conclusion, we learn about the PCR pass combination. We discover its advantage and its disadvantage. The advantage of it includes convenient for long distance communication, has a higher transmitter efficiency and has a higher noise immunity. The disadvantage of the PCM is that it requires a larger bandwidth compared to analog system, and also the decoding, and quantizing circuit is very complex. PCM are widely used in the satellite transmission system. It is also used in space communication and telephone. The compact disc CD is only one of the more recent application of PCM.